Hello and good evening. Thanks for joining us in another NYJavaSIG event. During the presentation, I ask you to use the chat to ask your questions and comments about the presentation. To start with, please use the chat and let us know where are you from, where are you listening from, and also if that's your first time at the NYJavaSIG. With the NYJavaSIG, we are in different social media platforms. Twitter is where we are more active. So everything about NYJavaSIG, all of our events we post on Twitter. So if you want to be notified about future events of NYJavaSIG, please go to Twitter and follow us. Our website, javasig.com. And since you're here on YouTube, please go ahead, click the bell, hit subscribe. There is a vast library of videos with all of our past events, so you can follow us there, and also you will be notified of any event, any new video that we post. Today, the talk is a journey to Spring, containerization, and Kubernetes. We'll go through the user cases and how they can make shipping Java apps easier and what's required to adopt them. Our speaker, Aaron Wanjala, is a developer who spent years shipping Spring Boot and Angular apps. He's passionate about web app development and loves telling stories to share his excitement with others. With that, please, I would like to welcome Aaron. Aaron, we're very excited to hear you. Please join us. The stage is yours.
Thank you very much, Rodrigo. I hope everybody can hear me all right.
You're good.
Hello, everybody. Awesome. As you can see, I'm Aaron Wanjala. I'm very excited to be here talking to all of you today. I'm actually calling from Waterloo, Ontario, in Canada. If there's any other people from Waterloo or from Canada or anywhere else, I'd like to hear from you in the chat. And yeah, I'm a developer advocate, Java developer advocate with Google Cloud Platform as of pretty recently. And you may be wondering what the role Java developer advocate actually entails. And really, it's just my job to help GCP become as useful as possible to you, the Java dev community. And that's why I'm excited to be here, to hear from all of you and hopefully share some useful information. So if you're interested in hearing, or if you're interested in letting me know what you'd like to see changed or added to Google's offerings, or just talk about the Java development community in general, I'll be hanging around after this session to talk. And I'm also available on Twitter at AaronMW and GitHub at Mookamik. So prior to joining Google, I spent the last several years building, shipping, maintaining Spring Boot apps and also Angular apps in a variety of environments. And by environments, I mean professional environments. I've spent time in smaller startups where we had kind of smaller apps, lots of control over what CI/CD and what delivering to prod looked like and what we wanted prod to look like. But the smaller dev team also meant that we had fewer resources to go around, and these teams may not have smaller teams may not have the headcount to have dedicated ops people. So it was imperative when we were doing our arch decisions to decide what our ecosystems should look like, that processes are easy to maintain since everybody will likely have to learn them. And then I've also worked in larger, more formal environments where we may have lots of dev and ops resources, but also significant legacy apps and other considerations that complicate changes to CI and CD, along with making changing prod environments and dev environments very difficult. So these teams, while they may have the headcount necessary to meet these challenges, they sometimes come with those more significant compliance or policy requirements. And I'm not trying to say which one of them is better or even which one I preferred. I saw pros and cons in both of them. And I just wanted to mention that having worked in both, I see that there are trade-offs in really any case that you'll end up in. And I hope that the concepts that I cover in this talk will be useful for difficulties faced in any of these cases, small app, small team, big team, something in between. Speaking of such difficulties, a few of the ones that I've run into that are nearly ubiquitous, that I've seen almost everywhere that I've worked while deploying Spring Boot apps, are a reasonably large, maybe unreasonably large config burden to get the project going, especially when it's a new dev or a developer that's switching from another project onto a different one. There's also a problem with production environments being somewhat different from testing environments or staging environments, sometimes very different. And this may just be because of changing processes. Maybe you've had to delay a release, and then things have changed more than you'd like, or you have to accommodate a client that's on an older version. There's lots of reasons to have those two get out of sync. And then also another big one is unrepresentative tests, meaning that especially when it comes to integration tests, it can be very hard to get certain specialized resources that you need in place to be able to test meaningfully without just like circuit breaking and kind of black boxing everything. Oops, I just hit escape. We're back on track. Okay, so during this talk, I'm hoping that we can cover some tools and practices that'll help alleviate these problems in whatever situation you're in. And I also think, just in general, when talking about new tools or practices, I like to provide as much context as possible, or as much as necessary, in order to talk about kind of what solutions came before the tools that I'm talking about or that I'm being shown, and kind of what motivated the creation of these new ways of doing things, these new tools. And so we're going to start by taking a few steps back into history, taking a look at Spring and why the Spring Boot extension was built on top of it, as well as a bit of what was before Spring, before we work up all the context we need to discuss the new shiny tools that are being released today, because I think it's that context is valuable in understanding kind of what's happening and where the community is moving. So the year is 2003. There's a ton that can be said about developing in J2EE versus Spring, and there are a lot of people online who are willing to say it, and that's excellent. But for the point of this talk, we will suffice it to say that J2EE was somewhat like a buffet of components, where Spring offered a more opinionated menu of tools and modules to build web apps. And Spring presented, a set of ready interfaces for things like security that every web app is going to need. And that was an excellent quality of life improvement for developers because it allowed them to focus on the essential complexity of making their app rather than finding a security vendor or figuring out how a security vendor's servlet components would work, or in the worst case, making their own. So Spring came out with lots of these nifty modules for devs to use, but of course, it still had lots of room to improve. Lots of folks were skeptical about Spring being kind of its own ecosystem and being proprietary as well. Even though it was open source, it just worked differently from EJB, I believe. So,
Aaron, just one second. If you're sharing, we're not seeing your screen.
You're not seeing my screen?
No.
Oh boy.
We see you. Yes, there you go.
There we go. Thanks, oops, sorry about that.
Not a problem. Thank you.
Thanks for letting me know. Yeah. Okay. Yeah. So there was still quite a bit of config. If anybody's developed in Spring, you'll know that compared to Spring Boot, there's quite a bit more config to deal with. But nonetheless, actually, my screen didn't change when I hit next. Oh. Okay. Yes, now it is. So nonetheless, several years passed. Spring was a very successful framework. It grew in adaptation adaptation for several years, over several major version releases, and now it's a very significant framework in the Java community. But around 2012, there was a call from the community, and they wanted, among other things, they specifically asked for a simpler, more unified configuration format for common web container services, so that you don't have to wrangle with how each servlet component decided to architect itself. And that was a lot of specialized knowledge that was kind of grating on the community. And then also they wanted a unified component model, similar to that. They wanted simpler dev tooling, so you didn't have to build or use a complex IDE to construct a war to then deploy into a dev container just so you can execute your main class. Like, it was a whole lot of steps. And they wanted an embedded servlet container because that was just something that like almost every web app needed the web server part of it for the deployment. So in fact, actually, the call and response for from the community and from the Spring org is preserved in GitHub issue history, and it's available at that link on screen. You can kind of see what the community asked for and how long it took for them to respond. And it was a little less than 18, well, maybe right around 18 months later in 2014, Spring Boot released an extension that was like a project built on top of the core Spring framework. And Spring Boot was born. It was a response to that very specific call from the community. And it was dramatic. It dramatically cut down on the amount of config required to get off the ground, unified those disparate approaches, trimmed things down to the point where a functioning controller could fit in a tweet. And so here we are, almost 10 years later, and you're able to go to start.spring.io, use the initializer, and have an app with dependencies ready to run on whatever version you want with just a few clicks. So I would say that this path that we started going down was a rousing success to this point. And I think that that kind of ends the first section of talking about the progression of Java from the development side. And I think that that series of steps from J2EE to modern Spring Boot, not that J2EE is necessarily bad, it's a great illustration of the community progressing towards saving development time for useful dev tasks and kind of focusing on what they saw was valuable. It's a great story for the open source community too. But I'd like to take a minute to talk about how these apps were being deployed kind of on the ops side of things, to take a bit of a break from the development side of things in my next section. Before I move on though, I just want to check if there are any questions in the chat that I should get to in this section.
None so far, Aaron. I'll let you know.
Sounds good. So I think this will be, this is where we're getting to we're getting close to the Kubernetes part. So traditionally Java apps, we're talking about how these apps were deployed kind of along the way. Traditionally, way back, they were deployed as long-running processes on conventional servers. And this wasn't all bad. The JVM was very optimized for long-running processes. And it by large machines, like when I say traditional deployment on a large machine, this is a large machine in terms of resources that either was running many different things, or sometimes it was one machine that was dedicated to running one very well-resourced instance of a large application. But in either case, the decision was made because it was pretty straightforward. You could just kind of deploy it and support it just like a regular computer, because it was, a physical server fully dedicated to your app, and you could just do your maintenance and deployment through the shell. Perfect. There were significant drawbacks. These servers were often running other apps, which led to situations where one app can take more resources than you'd like, and then that affects the performance of other apps that kind of butts up against the resources that it was supposed to be taking. These are known as resource boundary issues. And on top of that, there were, these servers were running non-critical daemons and processes all the time, had lots of unused and underused compute time, and scaling was very hard with these servers, because whether you have one server running 10 apps or one server running one app, if you want to scale, you have to, get another machine, provision it, set it up, maintain it. And then if you want to deploy, your deploys are multiplied by those machines. And speaking of the deploys, they were much more complex and high touch in these days, often involved people manually taking steps, so they were limited to human speeds. And those human speeds were a killer because it sometimes required outages or downtimes in order to get your changes out there. For these and several other reasons, folks began using virtualized servers instead, which helped. It solved a lot of the resource boundary concerns while also improving security, because as you can see here, the OS is boxed within the virtual machine. And so that simplified deployments and maintenance and reduced cost. It was a big leap, but unfortunately, it still involved running all the components of an app, including the operating system, on top of the virtualized hardware, meaning that even the smallest change to your app would require you redeploying all of that. And especially back in the day when internet speeds were more constrained, not a cheap proposition. And so that brings us to the modern container era, which we can call, for the sake of this talk, the end of history, because we're right at the right side of the screen. And so as you can see, each container is responsible only for its app and its own dependencies. This means that the isolation properties are actually more relaxed than VMs, since many containers can share an operating system. But each container is still independent. They have their own file systems and memory and process spaces. And you may even see pretty often that apps start as process ID 1, and then if you kill the container, if you kill the app, the container dies, because that's process ID 1, but you can alleviate that. I'm kind of getting off on a tangent. But these containers, the point is these containers are portable and decoupled, meaning that once your app works in a container, you can take it into any system, whether it's on-prem or on many devices on-prem or in a public cloud or wherever else, and you can be sure that it'll work just like it did on your laptop. And the fact that these containers still only hold the app, the binary, and the libraries helps resource efficiency tremendously, and also makes app performance more predictable. Because this time, as long as your container is built progressively, you're sure that when you make a change, you are only necessarily pushing that change. You're not pushing all of your dependencies. You're not pushing the OS. You're not pushing anything else. It's just the smallest possible unit of change for what you want it to do. So that's actually, let me take a little bit more time to explain that detail. When I say progressive building or layering, this is a process that separates the parts of an image that rarely change, like the dependencies, so that they are built separately from things that change frequently, like your app code. So if you say like your whole deployment is 95 megabytes, and 5 of it is actually your app code, and the other 90 is your dependencies and all that. In 2 of these 3 setups, you'll spend a lot of your time and resources building and sending and waiting for and starting up, like just slowing down your whole process for this 95% that isn't useful. Whereas on the container deployment, you can cut down a lot of that time by simply not pushing all those extra bits all over the place. And so the end result is that both your initial development and long-term support gets cheaper and more efficient. So when we talk about containerizing apps, and especially containerizing it in a progressive way, or an incremental way, I should say, how should we go about it? If you have an app to deploy, how should you, like, what methods are there that you should consider containerizing it with these days? Well, good news, there are a lot of good options. I'll go over 3, and the first one, and I'll go in order of difficulty. The easiest one, especially for a Spring developer, is as of January 2020, when Spring 2.3.0 milestone 1 build came out. You can just build it with a single command here on the left, where you just go Maven Spring, or you just go Maven W Spring Boot build image, and it'll use Paketo build packs under the covers and do a full layered build for you, requiring no extra config. Ships with milestone 1 or greater, and works like a charm. So that's probably the easiest one. Another option is Jib, which doesn't require you to, it also doesn't require you to touch or really understand Docker files, which is nice, especially for like a smaller team environment where you may not have all that much extra time and personnel to train everybody on proper Docker file maintenance or layering. And we will be going more into depth on Jib in the demo section. But for now, all that really matters is that to get it going, all you really need is to have an app to containerize. You need to have a repo to push the image into. In this case, it's gcr.io because it's a Google Cloud project. And GCR is Google Container Registry. And then you just need to add essentially this plugin to your POM or your build.gradle or your Bazel build, whatever package, whatever build tool you want to use. And then you run a command, which I'll be showing in the future in the next few slides. And it's just a compile command that pushes the image to the repo, and that's it. That's all that's really necessary. As long as repo is there, you can do it in one command. And then the third way is the most difficult, but I wouldn't say that it's the worst or anything. It's like it's more specialized. So there could be all kinds of reasons that your team or your CI/CD pipeline or just your situation prefers Docker files. And in any of those cases, you could just like the easiest way to go about it would be to just dump your whole jar into a Docker file, which would work. But it is not a good solution for the same reason that we moved off of the first 2 methods of the deployment from traditional to VM to containerized. You would be pushing extra bits that you don't need to be sending around. And so This would slow down your process, make maintenance more expensive, and especially in production where you may have customers waiting on the other end for your app to come up or for your your app to scale at peak time, something like that. And resources are often at their most expensive in production as well. So it's just not advisable to use an unlayered jar in this way. Instead, what you want to do is unpack the jar before building the Docker image. And there are a couple ways to do that. Just recently, there has been a new tool released, and this link on screen is also at the bit.ly link in the chat, and it's a write-up from the Spring organization, from the Spring Framework team, that explains what this Java jar mode tool does, how to use the layer tools to build a Docker file the way you need it to manually. And this isn't terribly difficult. It's not a one-liner, but it's a great tool that you can just kind of mix into your Docker files if you want to have that level of control. So it's an exciting change, in my opinion. I hope that this article is useful. The only thing that I would advise is with this article, it was written on the milestone 1 build of 2.3.0. And since the milestone 1 build, they have changed the config property slightly. So I believe they changed it in milestone 4 so that the config that's in the article won't work, but the config that is on the slide here will work. They changed it from like an enum being of type layer to configuration layers enabled. So they've changed the nesting and changed the value. So, and I think they keep all of their articles for historical reasons. So they're not going to update that, but people in the comments are letting you know. So just so you know, if you follow that article, you can refer to either the repo that's in the bit.ly link, or you can look at the comments to find the correct configuration. It won't work straight out of the article, but it is still a good tool. Yeah, so there is another approach. In case Docker files are a requirement for your situation, you can still containerize your app, no problem. And to remain on the containerization track, but still kind of flip back to the dev side of things off of the ops side, I want to talk about test containers. So if you have ever been in a situation, I actually described it in one of the first slides. If you've ever been in a situation where you want to test an integration, you want to test it meaningfully, but because the integration is so obscure, or because connecting to it would be so strange from your CI situation, or locally, or in whatever situation you wanted to test, you're just kind of you're relegated to just like black boxing it and kind of mocking the test, and you're not even sure if the test is that useful. What you can do is you can set up a test container, which is essentially a Java library that supports JUnit testing and provides throwaway instances of databases or Selenium WebDrivers or any other resource that you can fit into a container that'll help you complete a test, right? And so as long as you can make a Docker image of the resource that you need to meaningfully test your integration, you can turn that Docker image into a test container, and then that test container can help you be confident about how your app will actually act on deploy. And so this is going to be the first demo for the session, and we're going to take a look at this in action. Just switching over here. I hope you can still see the window. I hope I picked a window instead of tab.
Yeah, you're good.
Good. So this repo is the repo that we'll be using for the examples, the demos for today. And yeah, so what we'll be doing is just on the main branch, we have everything we need here. I've just got to reconnect to my Cloud Shell. Speaking of the Cloud Shell, I don't need to be using the Cloud Shell here. You don't need to use the Cloud Shell if you wanted to follow along. There are instructions in the GitHub repos. You don't necessarily need to use the Cloud Shell to do that. As long as you have Docker available, as long as you have a Kubernetes environment available, which you can use Minikube for, and as long as you have Maven and Java, you're good. You don't need anything else. I'm just using the Docker, or I'm just using the Cloud Shell because it's convenient for me to build a GCR project and authenticate easily. But with minimal effort, the definition of like a service account, I could move this demo over to my command line and just use the gcloud CLI. So just so you know, not a requirement to use Google Cloud Shell for this, for any of it. And so what was I doing? Yes, the getting the.
No, if you can just increase the font size.
Oh yeah, absolutely. Thank you. I always forget to do that.
Right, thanks.
I'm really not using the editor quite yet, so yeah, this should be good. Is that good enough?
Yeah, much better.
Awesome. Thank you. Oops. I always get that slightly wrong. There we go. So I'm just setting the project ID for my session, and then I need to check the status of where I'm at, just to make sure I'm on the right, oops, into the repo, or CD into the repo, check them on the right branch. I am. Excellent. And so all I'm going to be doing is following the README instructions. I want to build the jib image that is, maybe actually before I do this, let me explain the code that's at that's on this branch. So it's a fairly simple Spring app. It's really it's a bare bones test containers implementation. The controller actually doesn't really matter. What we're interested in is the test. And so all you need to get it going is the test containers annotation, which kind of injects a whole bunch of Docker utilities that you'll be needing. And then you can specify your image name. You can do this in a number of ways, but this is how I've chosen to do it. And then once you have that handy, you can, whenever you're running a test, you could do this in a before, so you can use this like the same setup for several tests, or you can do it test by test. You can just have a try with resources that essentially handles the container as a resource at the end of execution. So there's no leaks and there's no issue with having to shut containers manually. It opens up an instance of the container you specify here. It is throwaway. It comes up for the test. It discards itself, and it is always the same. And so you can run whatever SQL statements you want. I'm just using the regular like result set stuff, but you could use JPA. You could have spell expressions going in here. You could do whatever you need to do. And then just to keep things simple, I just have a perform query helper and a data source config here. And really that is all that is necessary for me. And so to run this test, all I really need to do is ww test. And then you'll see the output briefly, not briefly, but shortly, in the console here, where it starts running the tests and it says, I'm doing all these outgoing connections, and you'll see Docker come up and it is spinning up the containers. Well, I'm not running it locally, but if I was running it locally, you could see my Docker engine creating the containers and shutting them down as necessary. And then you can see the output of my test. I believe it'll be just a success. It's a fairly straightforward.
Hey, Aaron,
Yeah.
sorry to interrupt. Can you increase your font a little bit more?
Absolutely. That.
Much better. Thank you.
Yeah, no problem. So yeah, you can see that the build succeeded. It only took 28 seconds. You don't have to run this all the time. You could have this, like say you have Git hooks that require you to run tests. Maybe you don't want to take 30 seconds to do every push. If you push frequently, that's fine. You can just have this only enabled in CI, or only when you're graduating from silver to gold, or when you're putting a build into Canary, whatever your vetting process is. This whole talk is kind of set up to be, standalone approaches that you can kind of combine into your into whatever works best for you. So there's our first demo here. We go back to the slides, And again, this is just another huge time-saving contribution. If you've ever been in a situation where you're not sure about an integration, you end up releasing, you end up having to do like early life support or some other, like trying to catch it in staging. There's just a lot of guesswork involved that this can help reduce. So I hope that if you have an obscure integration, maybe you can find some time with your team to try to fit it into a test container and then try to make a more meaningful test to kind of handle it. Moving on to semi-recent news on the language side of things. The Docker container detection feature was released in LTS. It's been in preview since I think 9, maybe 8. I think it's 9 though. And so what does that actually mean for us? It means that the JVM is now aware when it is running in a Docker container, and it will extract specific, like container-specific configuration instead of querying the operating system or attempting to in all cases. And so the information being extracted is the number of CPUs, total memory allocated to the container, total CPUs available to the Java process, CPU share, CPU quotas. It can get very granular. And in fact, the old, if you were familiar with the old RAM fraction flags, those are replaced now with percentages. And a change from, I believe, Java 9 to 10 is that it's enabled by default and that it is disableable by the command line option. So this is a big update, like a lot of functionality coming out here for containerized monitoring. This is not like brand new. This is March 20th, 2018. I should say that. But it's still a big update for containerized monitoring, and it kind of paved the way for a lot of great tooling since then. The best place to be to take advantage of all that tooling, of course, is in an environment where the tools you're using are able to adapt to the new flow of information that these new options would offer. And so to cover those kinds of environments, we're going to need to cross over from just the world of modern Java development plus containerization. And we're going to have to add the element of container orchestration, where we will at long last, almost 30 minutes in, mention Kubernetes, but I swear it is worth the wait. So container orchestration. Maybe you've heard the word before. We're going to start using the word orchestration a fair bit. So let me try to explain kind of what I mean by orchestration, or what you can take it to mean in a lot of these situations. When folks say orchestration, they're often describing an act where instead of having your system say, I want specifically this device, I want specifically this resource, give it to me because I've identified it with like a hard link, you're instead able to describe what kind of resource you need, the type, the size, the amount, etc. And then rather than selecting it yourself and kind of being tied to it, you can allow a system to select something that fits your needs and send it over to you. And that allows you to, rather than relying on individual resources and breaking otherwise, you can treat any resource that fits your requirements as interchangeable instances of that resource. And that's a very helpful approach when it comes to stability or trying to reach global scale. And we'll be applying it to all kinds of resources, not just CPUs, not just pods, but things like storage, things like, all kinds of things. And when we say container orchestration, we are going to be talking specifically about, I just wanted to like briefly talk about the overview of the category, but we are going to be specifically talking about Kubernetes using the Docker container runtime in this talk. So starting with the name, Kubernetes comes from the ancient Greek Kybernetes, which I may be saying completely wrong because I'm neither ancient nor Greek. And it means something along the lines of helmsman or pilot or captain. Definitions vary. And actually, fun fact, the premier package manager of Kubernetes is called Helm, which I'm assuming is another fun reference. And you should definitely look into Helm if you're looking to learn more about Kubernetes. So it's a lot of people are doing great work in distributing it on Helm. So yeah, Kubernetes is often shortened to K8s, sometimes pronounced Kates. I don't really pronounce it in either way in particular. I just say Kubernetes all the time. And so its origin of like where the actual technology came from. Google developed the ancestor of Kubernetes, which is like a predecessor system. It was internal. It was called Borg. You may have heard of it. But if not, Borg was well before my time. So Borg was something that that was used to it was the internal compute cluster manager, and it was capable of running hundreds of thousands of jobs from thousands of apps across bunches and bunches of clusters that may each have had tens of thousands of individual computers on them. And as you'd expect, a whole bunch of interesting lessons were learned from that practice of running it from 2003 to 2013. They were, I'll say we learned a lot about minimizing idle time and maximizing fault tolerance. So, making sure it's working as hard as possible. And if something were to fall over, how much stuff can fall over before an outage occurs? How much can you minimize the recovery time from one of these fallover events? And can you get down to the process to isolate performance, and what kind of monitoring can you do? How granular can you be with it? And all sorts of interesting questions like that are all detailed in a paper that I've linked at the top here, and it's also in the bit.ly sheet if you're interested in learning more. I think there's a ton to learn here, and especially when it comes to Kubernetes, so much of what I've benefited from is from reading and from coming across situations in production or in like other deployment environments that I just would not have found in any tutorial. So I would encourage you to take a look. And so, yeah, 2014, the year after, Kubernetes is released as an open source version of Borg. A lot of companies sign up, but also a lot of individuals. I want to highlight that for sure. A lot of good open source contribution there. Google's contribution to Google actually contributed the version 1.0 of Kubernetes as a seed technology of the Cloud Native Computing Foundation. Cloud Native Computing Foundation is hosted by the Linux Foundation, and there are lots of other founding members to the Cloud Native Computing Foundation. But yeah, that was Google's contribution. And Kubernetes has been thriving at CNCF ever since. Is Kubernetes the only container orchestration game in town? No. There are other options like Docker Swarm and Apache Mesos as well. They have their merits, but I'm going to be focusing on Kubernetes for this talk. And now that we have chopped through all the background, we have the context we need, let's get to know how to actually use Kubernetes and how it actually works. So this next slide, it looks busy, but we're going to be walking through it, and I promise it's not as bad as it looks. One sec. So when you deploy on Kubernetes, you get a cluster, which is the gray box here. And that cluster contains a set of worker machines, which are called nodes, the smaller gray rectangles here. And each cluster must have at least one worker node. And each node hosts the pods, which the pods in here, the little kubelets, are the ones that actually handle the workload of the application. And a pod represents a set of running containers in your cluster. It could be one, could be many. Each pod gets its own IP address. Pods can communicate with all other pods in the cluster as if they are in localhost. That's sometimes called pod local. And the cluster also that's the end of talking about nodes. Moving over to the control plane. The cluster also contains the control plane. And this is a very important part to understand. This is like learning more about the control plane is what made me feel like I understand Kubernetes. That was kind of when the light bulb came on. And so what I mean by the orchestration layer is this is where all the work that happens in order to define, deploy, and manage the life cycles of your components, like your containers and all of your APIs that are necessary to do this work. And this includes something called the Kube Controller Manager, which is a component that runs controller processes. Controller processes are less complicated than they sound. They are just loops that watch the shared state of the cluster and look for differences between the current and desired states. Those are important concepts. The current state is what Kubernetes detects on the system right now. And then the desired state is whatever you told it to get to. And whenever necessary, the Kube Controller Manager will make moves to bring the two closer together until they match. And so when considering the control plane, I found it really helpful to think of Kubernetes as a document storage system. A document storage system where you, as the developer or ops person, hand Kubernetes documents, and these documents describe how the world should look. When Kubernetes has your documents in hand, once it gets to that point, it both has it knows what the world currently looks like because of the controller process is constantly watching those loops, and it knows what the world should look like because of the documents you've given it. And so it is empowered with the manager to get you there by starting your containers, or if you like starting your containers if you're short on a quota, or killing unresponsive ones if they're not healthy, or whatever else you've agreed means unresponsive. And so I think those are a lot of the highlights of Kubernetes. One more thing I want to get across before we move on is that in order to communicate with anything that's further away from a pod, like if your app is in here in a kubelet in a node, and you want it to communicate with Twitter, that is further away than a pod. Twitter's not another pod in your cluster, so you will need a service. You will need a way to expose your application as a network service so that you can. Like services are also responsible for mapping incoming requests back to a given port. It can take a request on any port and map it to any other port. And we will talk about that config as we define our first service. But yeah, there's a ton more to learn about Kubernetes. There are more links in the bit.ly document that I've attached, and I encourage you to do so. But for our purposes today, really in order to build and maintain apps on Kubernetes, these are all the concepts you need to grasp, and you can kind of pick up the rest as you go along. So we're going to move on. So a couple things that Kubernetes is not. Kubernetes is not only for stateless apps. It's not only for certain types of applications, not stateless, not stateful, not for data processing apps. If it runs on a container, it should be great on Kubernetes. And then also Kubernetes is not a machine configuration system. It's not a machine maintenance system or a machine healing system. It won't actually restart your servers, is what I'm getting at. It's a software orchestration system. And another thing is that it's not a provider of app level services like databases or message buses or data processing. Those last two are just kind of out of scope for Kubernetes. Especially with the app level services, that's been a deliberate choice to not. It seems to me that it's been a deliberate choice to not mix those things in. They'll sometimes tie them in as proof of concepts, but they won't make them important parts of it. So, and then the first one is more aspirational. It's just, when Kubernetes was Borg, it was running all kinds of jobs on it. So, why shouldn't the open source version be able to? Things Kubernetes will do for you. Well, it'll offer service discovery, load balancing, and what those mean is like you can expose containers by either DNS or IPs. You can load balance them to distribute the traffic amongst your instances and keep every instance stable. And in case you're wondering like what algorithm or what selection method is used for load balancing, it's not a round robin. And there is actually a very good reason for it not being round robin. But yeah, it's there are a number of options, and yeah, I think I'll leave that there. The next point is storage orchestration, which allows you to automatically mount a storage system of your choice. Very important. This could be a local drive. It could be a public cloud provider like an S3 bucket or a Google Storage Link, or anything else that you want to act like storage. So that's great to have kind of that abstraction over the layer. We don't need to know. We don't need to get bogged down in the details. Just treat the storage like storage. And of course, that helps when you're, handling millions of requests a second, and you need to change environments, and you need to act the same way in all of them. Automated rollouts and rollbacks. Once a document gets updated in Kubernetes, once it's applied to Kubernetes, it will just go ahead and handle the deployment. And if that deployment goes poorly, you can roll it back. That's a nice feature. One more thing is, well, two more things. One more thing is secret and configuration management. You can store sensitive data like passwords, tokens, keys, all that, and update them without rebuilding your containers or exposing secrets in your config. This is an underrated aspect of Kubernetes, and I think it often takes people a while to get to fully enjoying this aspect. But if you're a proponent of like the 12-factor app development philosophy, I think the third factor is keeping your config separate from your code, because there's just no good reason that changing a key in your app, like if for some reason you needed to change a bunch of keys in your service, or if you needed to change all your passwords, it would be great if that didn't require a full deploy. It'd be great if that was just an ops person going into your config maps, setting the new values, and bouncing all of your pods, and they're up in seconds, rather than having, in the worst case, to rebuild and repush and redeploy all of your bits that are the exact same, just so you can change, or nearly the exact same, just so you can change a couple values on a couple keys that are staying the same. It's just it's a sticky situation to be in. And then automatic bin packing. This is another underrated one. You can tell Kubernetes how much CPU and RAM each container needs, and then you can set up a cluster and allow it to fit containers into the nodes in the most efficient manner that it can think of. Yeah, I wish I had time to add in a demo for that one. Yeah, maybe another time, but that's a good one. Yeah. The self-healing. This is where I said earlier that we would do a jib demo. This is the jib demo. And so if we think back to the earlier explanation of Kubernetes components, and remember that the controller loop is constantly looking to correct the cluster state, the result of this is the self-healing property. Whenever a pod is seen as unhealthy or missing, the controller will act to correct that. So I'm going to switch over to the console, and we can see that in action. And if there's any questions, I'd be happy to take them as I do that.
Yeah, Aaron, we have one question from the audience, and that's on the test containers. Do we need Docker on local PC for test containers? If you want to try that out.
It's a good question. No, you don't need Docker. Well, no, you do. Sorry, you could. So if you wanted to develop without relying on any other systems like Cloud Shell, then yes, you would need to install some Docker client. But if you were okay with using a cloud-based system like Google Cloud Shell or Katacoda or something else like that, you could just kind of send your job off. But whatever's hosting the tests running has to have Docker. Yes, that's okay. The answer.
And the other question is from me, actually. I wanted to ask you about, so I've always been confused about the memory that a container needs and your Java application needs. There's always a percentage, right? It's like 50 to 80% you should keep it. So do you have any like thoughts or ideas about that? Like, what is the standard? I guess that's what I wanted to know.
So I think that is a really good question. It's a very opsy question, and I think that would depend on what you're running in the container, because if you're running like distroless Java, that would cut it down quite a bit. Whereas if you're running something that has a whole bunch of other aspects to it, that would affect it. I don't have a great answer for you. My instinct is to try to automate that away. And with a lot of services like GKE, you're able to just not specify resources like memory and then have it auto like vertically scale your container based on need. So that would be my suggestion.
Thank you.
No problem. Thank you for the questions. All right, so the jib demo. Great. Let's we're actually staying on main, And we're just going to follow the README because the last demo was just running the tests. This demo is now actually building the image with Jib. And then once we have the image built, we're going to create a deployment. It's not a GRAL deployment. It's just a basic Jib deployment. Sorry about that typo. And then once the deployment is ready, we're going to take a look at the logs, see that it starts up, and just kind of see our new container running. So I'm going to probably have to re-up. No, I'm okay. Yeah. So what we're doing here, I should have explained that command actually. What we're doing is we're just setting the project ID because I like to parameterize my sorry. Whenever I'm doing bash scripting, bash things, I like to parameterize it so that it's more reusable when I come back to it later and I've forgotten half of it. Or if I'm showing somebody else, they can reuse it on their project more easily. So I'm setting the project ID as a variable, and then we're passing it into Maven compile, where this is the Jib command that comes with the Jib Maven plugin that allows you to, that allows you to build your app and build your app into an image, store it on GCR, and yeah, kind of push that in and use it for whatever you need to later. So that's the one-liner. It's not the shortest, but it's pretty concise. It's memorable. And then yeah, so now I can see that does not exist locally. I think it's a little strange. The build succeeded, and I'm fairly sure the image does exist locally. So I'm going to continue. And so what we're going to do is we're going to create the deployment. This is our first deployment, so I'm going to go over it in a little bit of detail. So when you, first off, whenever you say kubectl apply, and then you can pass in a file with -f, you're telling Kubernetes, this is a document that I want you to update the world to match. It could be a config map, it could be a service, it could be a deployment, could be whatever, a single pod, but you're telling Kubernetes, I need this to be up when I look for it. And so what we're doing here is we're doing a bit of a bash trick to say, we're defining a here file where we're saying, until you see the end of this file, I want you to apply the contents here, which are API version, it's a deployment, having metadata with name basic Jib, and then we're setting a label. We're setting it to match the label basic Jib, so that if I want to find it by basic Jib later, which I do, we can do that. We're saying I only want one replica. We are defining a template and metadata, and yeah, a lot of this is pretty basic. But then with the containers, we're saying we want the container to be called basic Jib, and we want it to be sourced, the image sourced from gcr.io, the project ID basic Jib, where we just defined it, and we want to allow connections on port 8080. Yeah, and again, that because this is we don't have a service for this. This is essentially just a pod local port forwarding. Yeah, I don't think we're not going to use it, but that's an example of port forwarding on a pod or on a container. So yeah, that's about it. We're going to see a lot of deployments similar to that. Excellent. So what that did is it says Kubernetes says we've created a deployment called basic Jib. So if I'll just go ahead and use the next command in the list here. I'm going to get the logs for the label of run basic Jib. And so we're seeing that Tomcat started on port 8080. There it is. So we have built the jib image like we had said we would earlier, and we've deployed it with a new deployment. That's great. But now we want to show the self-healing property that I was just talking about before. So to do that, we're going to kill this pod. So we can, there's a lot of ways we can do this, but all we need is the pod name. So the most straightforward way, say,
Hey,
give
Aaron,
me,
I have a
hey,
question in the chat, if you don't mind. This is a good
oh,
one. There's a user who's saying, I have a successful Spring Boot-based monolithic app that uses a Postgres relational database. It currently runs on the OS, no containers, and user want the app to be highly available. Is Kubernetes all I need? And the second part is, and what changes, if any, need to be made to the app to achieve this?
So he said it's just running on an OS. Is that an OS in a virtualized environment or just on a traditional server?
I guess it's no containers. It's not mentioned, probably.
I'm guessing that, you know, you can probably, it's not a huge lift to take a traditional deployment and just create a container that matches the conditions of that original environment. And then once you have that, and even if you're not able to edit another line of code, you are able to use at least one tool that I know of called Anthos that will take your virtualized app, and it's a fully managed like application deployment platform. I'm not actually going to be going over it in detail in this talk, but there is a link for it in the document in the chat. And so I would advise that person to look into getting their app running on a VM, and then look into that Anthos user story that I linked in that document. And between those two, I think you might be able to get the high availability that you're looking for.
Thank you.
I would have to look into the situation more to be completely sure, but that is where I would start. So, and if there's any follow-up questions, feel free to ask. Yeah, gonna keep going. So, basic jib. We have one deployment, and sorry. No, I don't actually want. I want to describe it. Oops. Pods. Oops. So now that we have the pod's name, we can just delete the pod. But first, I want to follow the. Well, no. What we'll do is we will kill the pod. Then we will follow the pod, and then we'll follow the logs of the instance. So we've deleted the pod, and then we are waiting because we've passed the -f flag into the kubectl logs. We're waiting for a new pod that has the tag of, or has the label of run basic jib. And within 3 seconds, we found it. It was pretty much just the time that it took the JVM to start back up. And so we have self-healed. So that is the first property that we're going to be demoing of Kubernetes. And of course, you can see why that's useful. Like rather than having to get back on and or like wait for a monitoring alert to say you're not healthy and then page somebody or try with a script, something like that, Kubernetes is just ready to self-heal with nearly every pod. And so this has the side effect of allowing ops folks to sleep through the full night sometimes. And there are some containers, believe it or not, that you would not want this to happen with. Some examples are things like initializations, or just there's lots of reasons where you would only want a container to run once and then complete and not be auto-healed and keep coming up. And that is configurable, so you can do that if you need to. But self-healing is the standard. Next concept is auto-scaling. I think we should take a little bit of time to talk about the word scaling first, though. So when I say scaling, there's horizontal scaling, where you're running your store, and then your requests per second go up 10x. You can scale horizontally, where you put up more instances of your store in order to deal with the swell of requests, or you can scale vertically, where you just take your existing number of instances of the store, and then you just make them all bigger. You give them more resources, more RAM, more CPU, so they can churn through the same number of requests more quickly. So horizontal, vertical scaling, both can be automated by default in Kubernetes as of version 1.16, which was about 2 years ago, October 2019 at this point. Some cloud services offer scaling solutions that use different algorithms or have different controls, and that's great. But you may be asking, how does the auto scaling actually decide how many instances to stand up? And it's actually a pretty straightforward algorithm. It's the formula behind it is on the screen right now. And so let's say we're planning on scaling based on CPU. The unit you would use to describe how you're doing on CPU is called a millicPU. And so you can describe a container and say, I want this container to use 100 millicPU or 200 millicPU. And so when you say I want my container to use 100 millicPU, you're saying you want it to use 100 thousandths of a CPU. So if in this function, my desired metric value is what I set, like we can consider desired metric value as the value that I set for my container's CPU usage. So I'm saying I want my containers to use 10% of a CPU. And then current metric value is what Kubernetes is telling me they are currently using right now. So it may be saying your requests from the store have 10x'd. You are currently using, twice as much as you would like to. And then the rest of the formula's job is to bring these two values as close together as possible. And when I say as close together as possible, the default threshold at which it'll stop trying to bring them together is 10% by default. But that is configurable. You can make it closer or further. But for example, if my current metric value, if Kubernetes is telling me that my containers are using 200 millicPUs and my desired value is 100 millicPUs, I want them to be using 10%, but instead they're using 20, the number of replicas will be doubled, because 200 for the current metric value divided by 100 equals 2.0. And so that multiplied by the current replicas will result in doubling my desired replicas. And if it's an odd, or if it's a fraction or a decimal coming out of that function going into the ceil function, ceil stands for ceiling, as opposed to the floor function, which would always round down. The ceiling function always rounds up. So you're not getting half instances stood up, you're always getting bumped up. This is the standard algorithm that Kubernetes implements. It's on their docs page. Their docs are excellent. For the fifth time, I think, we'll keep saying that the docs are excellent, and you should check them out. But I'm not trying to tell you what to do. I just really like the docs. What was I saying? The scaling can also be based on custom metrics. You can trigger it with custom metrics. So if you're not satisfied with scaling by CPU or RAM or storage or whatever other metrics Kubernetes has by default, you could bring in a custom API. You could come up with your own resource, and Kubernetes can work with that just as well. I won't be demoing that. That is a cool concept, but I won't be demoing that right now. I will speak to how you can define it when creating a cluster. Of course, as I said, you can do this without any cloud platforms, but I am going to show you on Google Cloud Platform how, if you were using the gcloud CLI, which we will use later, you can enable auto scaling with with a flag. Enable auto scaling, then you can define the min and max nodes. That works out. And while we're here, I'll also talk about the auto scaling profiles, where balanced is the same one that's out of the box with Kubernetes. And then optimized utilization is an example of kind of the other cloud services offering their own algorithms, as I suggested a couple minutes ago. And this one is optimized. Sorry, let me zoom this in. This one is optimized for the purpose of scaling down as aggressively as possible. They want to optimize utilization as much as possible. No, it's not a desire to keep spare resources in this cluster, and so that means that it's not great for workloads that are sensitive on startup latency, because oftentimes when you're starting and stopping an app, you will end up in a situation called cold starting, especially with Java apps, where it takes a while. Like it took 5 seconds for our regular Jib app to start up, and that is not acceptable when you're talking about a customer sitting on the other side of that waiting for their response. It may be acceptable entirely if it's an eventually consistent system, or if it's just an asynchronous workload, or something that's unreliable that comes up sometimes and goes down for hours or days or weeks, and you don't want the machines to be running in the meantime. So yeah, just another example of how you can do auto scaling, how it can be used. And yeah, I think that's all I wanted to say on auto scaling. We are coming up to the end of the demos, by the way. Yeah, we're actually, yeah, we're doing pretty good on time, I think. Virtual private, sorry, I should probably switch back to the slides before I start moving the slides around. We were on auto scaling, now we're on virtual private clouds. Virtual private clouds are just a user-defined network within another cloud computing environment that can be used as an isolation layer, or as like an isolation layer for private data, or as a network to connect otherwise unreachable services. We are going to demo one of these in just a minute, along with a couple of other concepts at the same time. We made one in order to connect our Kubernetes cluster to our Cloud SQL database. So yeah, you'll be seeing one of those. And another concept here, this is kind of the last concept that I'll be, well, second last concept that I'll be demoing today. Init containers are a special type of container that, if you remember back to the definition of, or the explanation of how Kubernetes is kind of laid out, what the components are, a pod has one-to-many containers, and these containers, the init containers are a special type of container that have to run to completion before any other containers, any regular containers, can start. It's important to remember that they have to run to completion, and they can't error out. They also don't have the same lifestyle hooks or liveness or readiness probes as a lot of other regular containers. They don't auto heal. And so that means that if you have an init container that fails, it'll just sit there and halt all the other containers from starting until it completes, unless you do something about it. And this is intended. And sometimes that's exactly what you want for things like initializing a database, or just waiting for any other preconditions that you want your app to run inside of, or run on the condition of, to occur before you start your app. Speaking of preconditions and initializing, we're going to be talking about Liquibase. It's a quick detour. What is Liquibase? Just in case people haven't worked with it. It's an open source database schema change management solution. It allows you to manage revisions of your database changes easily. And it allows, like, the problem that it's solving is, say for example, you're making your app, especially at the start of app development, your schema may change quite a bit as you figure out kind of what you need and what your data needs to look like. But then, a couple good releases later, your database may look completely different from what it looked like at the start. And you may end up in a situation for all kinds of reasons where you need to either deploy what was previously out there, or you need to refactor, or you need to, there's a branching issue. There may be all kinds of reasons where being able to roll your database back as reliably as you can roll your code in version control will be an asset. And what Liquibase does by allowing developers to write database changes as simple markup like this is that one, it allows you to commit it to source control outside of your code, which is huge because you can evolve your database and your code base together. But it also allows you to ignore the underlying DBMS or SQL dialect that you're using. So you can write a Liquibase change set with largely the same syntax in XML, in YAML, in whatever markup language you want, and you don't have to write, except for in some very specific cases, you don't have to write the SQL that you're especially targeting. You don't even have to tell Liquibase necessarily which type of database you're targeting. It just supports a bunch of them, and so it's a very useful abstraction for making sure that you don't just have to send out a ticket and hope that a DBA picks up your intent and gets the database changes right by the time your code hits testing or staging or prod. In the worst case, you can make sure that they work together, and especially when you combine it with something like test containers, which I thought I had a picture of on this slide, but I don't. If you combine this along with test containers, it allows you to thoroughly test your database changes and be confident that your code will act exactly as you want it to. That they will hit your prod environment the exact same way that they were working on your test environment well before the deploy. And so that leads me to our combination demo, where we'll show test containers and Liquibase together. So while I'm getting that set up, if there's any questions, please feel free.
There's no questions. Well, actually, there's a comment. Can we insert winds of winter into this DB example? But yeah.
The winds of winter. That's a good one.
So I have used Liquibase in my project, and it's very interesting. One of the best things that I liked about is that you can run the SQL. You can try to run the same SQL again and again by mistake. It will not allow it, which a lot of us be aware of when we are making any database changes, right? So I thought that was pretty cool.
No, that's an excellent property of it, and it lends itself to these kinds of distributed use cases where you may have 10 pods coming up at the same time, all trying to check if their instance of Liquibase has any changes to apply to the database, and they can all hit the same database, and they can all check if their changelog is different than what's on the database, and if the database changelog is locked, nothing will happen, or if the hashes that are generated as you're describing, if the hashes that are generated by Liquibase based on what's in the change set are no different than what's in the database, nothing will happen. So it's very secure. It's very kind of protective of your data, even if you're putting it in some strange situations. So that's another thing that I love about it. The winds of winter, actually, you mentioned the winds of winter. Yeah, we can try that. So let me, I'll just do that on, so I'll go git checkout. I'll do it on the Cloud Shell. Git checkout. And it's been a bit of a long day. My brain's not working quite right when I'm trying to remember things. Liquibase. So here we have the changelog, the Docker file, and the jar. I think I don't know if I've actually described these. So what we have here is, let me step through the code, and then we can get to this change. Yeah, so actually we'll make the change here. So I don't remember how much the Winds of Winter costs, but I'm just going to pretend it costs 30. It's not like I really checked the prices for the other ones either. So.
Would you prefer Liquibase or Flywheel? Any preferences
I haven't
or
actually used
favorites?
Flywheel. So I guess I would default to Liquibase. Yeah, I haven't actually used that one. How about you?
I've also not used Flywheel, but I've heard more favorable comments about Flywheel than Liquibase. I use Liquibase; it worked fine for me, so I
Yeah,
stick to the simple ones.
that is fair. So what we're going to do here is we're just going to refer to the, so this is whoever asked to add the Winds of Winter. It's a good question. Thanks for that. What this what I'll do here is each of these branches has a README that essentially describes how to use each piece of what's implemented in the branch, but it's not prescriptive on what order you should do them in. It's not like a step-by-step tutorial because I'm hoping that they'll kind of be useful on their own, and hopefully you can kind of compose them into whatever you need. And so to specifically build the Liquibase Docker image and then tag the new build, this is what we'll do. This is actually a bit of a hack for my purposes because I didn't want to tie myself too tightly in. I just kind of copied it from the Maven cache that I already downloaded the connector jar from. So I must confess that's a bit of a hack. And yeah, so I'm just going to build the Docker image here. And we can actually go see the Docker image building. If I go to console.google.com, or even quicker, I can go to gcr.io, just go directly there. And, or not, or I can just end up in the same spot. GCR, history. Here we go. So what is it called? Demo Liquibase. Demo Liquibase. See that we've pushed the latest version just now. I'm surprised that it's almost the exact same size, but maybe the change is less than half a megabyte. Okay. Yeah, so then 4910. Yeah. So then we will, oh, did my project ID? No, it did. So yeah, with that in mind, that in place, we're going to yeah, we're just going to, well, we'll talk through, yeah, we'll talk through the rest of this, and then we will deploy this and see it working. So let me talk through the code first. From the controller backwards, this is just a simple book controller. And so what it's doing is it's saying, let's find all the books. You just go to /books, it's a gets all the books, and it finds them in order of price descending. And it also, yeah, it also logs how many books it found. But yeah, it's so that contacts, the controller contacts the book service. The book service contacts the repository, the book repository, and then the book repository uses a named query, or a derived query, sorry, to derive the actual SQL from the name that I've defined here. It's a JPA repository property. And so I'm just finding all by, and I'm not defining a field, so it just finds all. And then I'm ordering that by, where I say next, which is price, specifically descending. And so once we have all that in place, what it'll do is it'll go and look at books. And the book class is very small because I also put in Lombok because I am lazy and I didn't want to type all the like no args constructors and setters and getters and accessors and all that in two strings and hash codes. So I just put Lombok in to take care of all that. And that is most of it. The other things that are there, there's the application, and then there's a persistence config for Hibernate's sake mostly. We do have to tell it. We have to enable the JPA repositories, and then we have to define an entity manager factory, which itself has a data source, which requires a whole bunch of properties from the environment, and also the last two of which are the Hibernate properties. This one is Hibernate memory to DDL. I forget what that stands for. Yeah, so it's telling it mapping to DLL. There we go. Mapping to DDL. How should it behave when it's mapping, when Hibernate is mapping to the DDL, and what dialect should it use? Just some Hibernate properties. And then the dependencies. Let's talk about the dependencies real quick. So we're Java 11, GCP starter, Spring Data JPA, Lombok for simplicity, JUnit, about 5 of them for testing because it still has the test containers in them. And they're somewhere. Yes. Yes, test. So this is still just doing this. The actual database that we're connecting to is a MySQL 5.7 instance, and the test container we're connecting to is a MySQL 5.7 instance. So they are going to be at least within a minor version. Like there's 30 at some number between 0 and I don't know, some non-zero number of patch versions, but no minor versions between test container and what's actually running in the cloud. So that's a good amount of confidence for me that it's going to be very similar when I run a test in here versus running it over there. And yeah, so it's the same concept. So I am. The last thing I need to explain is the Liquibase. But yeah, I'm running a Liquibase change set against a Cloud SQL database that I also have a copy of essentially in a test container for whenever I need to make some sort of involved change. This is a rather simple example because it's MySQL 5.7, but you could imagine it being some obscure Oracle version, or even a HANA instance if you're an SAP developer. You can really get some value out of test containers in the more edge cases. But yeah, change logs. We've changed the change log. Excellent. I think that's it. I think we've talked through everything. Now we can just go through, and we've talked through almost everything. Now we're going to talk through how to deploy this sample app on Google Cloud Shell. So in order from the start to get this working, you would need to enable all the APIs that we're going to be using, which are Cloud APIs, container. So this is basically for authentication. This is for like accessing containers, or for running containers, for accessing containers, for connecting between the resources, as we'll see, for contacting SQL, and for running a VPC, virtual private cloud. And then you'll be creating the Kubernetes cluster. This can take about 4 or 5 minutes, so not super demo friendly, but doable. We've also got the cluster role binding, which is essentially just like defining a user role for me to do things with my cluster. It's pulling it from my core account, which is who I'm logged in as, is the shell, Cloud Shell. We are, we build the Docker image, push it to the registry. Sometimes that fails. It's usually because your authentication has run out, or if you're running it locally on a non-cloud shell, you may just need to configure Docker to be able to authenticate with your container registry. And then the config map, this is an important part. This is where all of your environment variables sit. And yeah, we define a good chunk of them at the start here, including your database driver, password, username. And then we create an address and a VPC connection to connect that database that we're talking about to our cluster. And these two commands can take a couple minutes as well, not too bad. Creating the database is the longest running operation here. And so I've actually wrapped it in an operation. This is something you can do on GCP. You can just say, let me know when this is done. And it will put it on a long running operations queue and let you know when it's done. And then once it's available, you can grab that IP, put it into your config file, apply the config file so that you can actually have it appear in your cluster, build the image, which is a doozy because the image you're setting your project ID, so you have that for all of the parameterized images later. You're setting you're setting your app image, your app name, and then you are making the file with Jib. You're building the image with Jib. You are doing the same here file trick to kind of inline the deployment. And so we're defining the Jib demo app. We are setting the init containers. So the init containers are, again, initialization, trying to do things to set up preconditions for our app, configure things. In this case, we are running a local-based change set against our Cloud SQL database to make sure that it has the data we need. And so that requires the image and the environment variables, as well as the other thing we're doing in this container is running the actual app, which is Jib demo from the image repository that we've set, port 8080, and we are passing it all the same variables plus the Hibernate ones because it needs them for test containers. And for JPA. Yeah, it is for JPA, not test containers, I believe. Yeah. And then we create a load balancer because we need, as I said back in when we were, back in like the 5th slide or something like that, 7th, 8th slide. If we want a service to be accessible outside of the cluster, it needs to be exposed by a service. And so that's what we're doing with the load balancer. It's accepting traffic on port 80 and routing it to port 8080, which is where we have our container set. And the selector is Jib demo. And that's the same as our app. So then once all that's done, you can wait for the load balancer to have an IP. This is just like a simple bash wait loop. And then once you have that, you can curl it and it works. So what I'm going to do is, because this was such a container that had, it's a demo that had so many long running processes, I did do the Food Network trick and fully cook the turkey and leave it in the oven before the show started. So I'm just going to demo it working here before I rebuild with Winds of Winter in case the image has disappeared. So there we go. We have 2 of them, Storm of Swords, Feast for Crows. And then now we're going to drop the pod of Jib demo, and then it should just pick up it should try to restart a new version of the app, which will start the init container and then start the regular container and get it all going. So let's do that. So we have Jib demo pod, and then we're going to go kubectl delete pods. This deleted. Take a few seconds to come back up. Allegedly, it's back up. Actually, we can see it. Logs-f deployments Jib demo. I get it to, okay, it's pod initializing, so that might mean that the Liquibase changelog is still running. So I can go pod, boom, and then -c. You can use -c to say the container that you're curious about. pod not found. Pods slash that. Yeah. Oh, one change sets checksum. Ah, yes, I've broken the cardinal rule of Liquibase in my demo fever. I'm not supposed to modify change sets. Oops. Yes, so what I should have done in order to add the Winds of Winter is make a new change set, of course. Well, you demo, you learn. So what I'll do is I'll go change set author. That's why the checksum didn't change, or not the checksum, the size of the image. Aaron, again, ID equals. The reason why I'm prefixing all of these IDs with a number is because when I'm looking at them in a database, it's much easier to see, rather than relying on a timestamp or something like that, it's much easier to see just by sorting which ones came first, or which ones are in the order that I want them to be in based on what I set them here. So add a DOD and Dance of Dragons, is that what I did? I do wish the autocomplete on Cloud Shell was a little bit, the Cloud Shell editor was a little bit better. It's a great tool, but I'm very spoiled by IntelliJ. And it was the Winds of Winter. So all we need to define for the change set is author. I mean, even I think just an ID does it, but author is also best practice. So we're saying we want to insert another book onto the bookstore schema, title of the Winds of Winter, and the price of 30. And so we're going to repeat the couple steps to rebuild this Docker container. And then we're going to see if it actually makes a new image. What's it called? Container registry. Yes, images container registry. So demo Liquibase. Just now, 161.5. Suspicious. Might have another crash on your hands. So what we're going to do is we're going to, since the Docker file is already, since the changelog has changed, we're going to just kill the pod again, but we need to find what the pod's name is. So get pods. I'm sure there's a nicer way to do this. I'm actually not generally a kubectl user. I've gotten pretty spoiled and used to K9s as well, so I'm not used to always using kubectl for this. Go delete pod this. And I want to logs. I'll need different pod name. It's running. That's good. It's a very good sign.
Aaron, just to let you know that we're approaching 90 minutes.
Yeah, sorry. I am getting completely sidetracked. We just assume that it worked. And then let me just go ahead and run this curl and see if we get the Winds of Winter. The Winds of Winter. There it is. I didn't get the Liquibase change set going, which I think is a pretty cool output, but that's okay. You know, you can see SQL. It actually doesn't even by default give you very good outputs. Anyways, good suggestion from whoever said that. I am going to move on. Looking ahead. So let's say that you are, sorry. So let's say that you are already developing in a cloud native environment, and you're looking ahead at kind of what's coming next. You want to know what's coming around the corner. Well, then we've reached your part of the talk. We will now be looking at what's coming soon to the community and how we'll likely be able to apply it once it gains more general support and once further along. So for a bit of background for this new and up and coming thing, we're going to need to talk a little bit about GraalVM. GraalVM, if you haven't used it yet, it is a JDK distribution that is a polyglot, meaning that it supports many, many languages. It supports like 7 or 8, I think, like Ruby, Python, Java, of course, C, C++, R, a whole bunch of them. And it also is it's cloud native and it's very highly performant, specifically geared towards boosting execution time of Java apps. And it is wildly successful at that goal. So the reason why the Spring Boot logo is here is because Spring Native is a new project that just entered beta on March 11th of 2021. And starting with Spring Native, we will now have the option by default to have GraalVM ship alongside of our regular Java virtual machine in order to support compiling your Spring apps into native images. This is extremely exciting, and I will show you why, because GraalVM, I have a branch here. I don't really need to show you that on GitHub. I'm gonna stash this change. I'm going to reset this change because I can't stash because I'm nobody for Git. And then I'm going to check out GraalVM. So here we are in Graal. And the big difference with Graal is that this is going to take a little while. Not like 10 minutes, but like 3 minutes. So what we're going to do is I'm just going to start this and then talk while it runs. So ooh, project ID did not get replaced. Is that true? No, maybe it did. Did. Oh, I'm in the wrong directory. It's getting late. So while it goes, GraalVM, what it's doing here is it's compiling it into a native image. And why that's important is because it's kind of a next step rather than like a new, or it's more of a new option than a next step is what I mean to say. Like where a lot of the previous things we've been talking about have been just improvements on the same track. This is kind of improvements in the form of a new use case where the JVM has been very well optimized for long running processes and handling those very efficiently. Graal is all about quick startups, and that's good because it's patching up a soft, like a weak point in Java deployments, which is cold starts. If you're trying to horizontally scale an app, as we mentioned earlier, it can be a real challenge if it's going to take you 5 seconds to get that app running. But if it's a native app, it can start much sooner, but that does come at a cost. So it's still going to be building for a little while. The build time is one of the costs. It's a much longer build process rather than being like 30 seconds. It's going to be 3-4 minutes. And this is still, that may get better during development. I don't have any information about that, but I'm guessing. Right now it is still experimental because it was just released in March. So it's not on Maven Central. If you want to get it, the easiest way would be to go to start.spring.io, go to the initializer, pick your dependency, Spring Native right at the top, experimental. That'll get you nearly everything you need. It'll get you everything you need, actually. And essentially what that'll give you is a Spring Native version. It will give you a plugin of Paqueta build packs saying you're using Tiny and you're ready for a BP native image. It'll give you the plugin, the AOT plugin that you need. It'll give you the repositories, both the repository and plugin repository that you need to pull the experimental versions of those dependencies. Another thing to consider is that it takes a ton of memory to build these images. You're seeing some build sizes here, 3.8 gigabytes, 3.9, 0.96. I think a lot of the MacBooks, a lot of the computers that I've worked on over my career would not be able to handle these builds. They would get error status 137s every time, which should be out of memory. So this might be something that you only do when you're sure you want a workload that is set to come up quickly and unexpectedly, and it needs to, and it's worth the investment of extra build time and extra memory in your CI pipeline to get it done. So in a couple seconds here, hopefully, we'll see the build pack come up. Hey, there we go. If it fails for some reason, I'm sure I can find an old version somewhere. While in the last few seconds while it comes up, the old, like the basic, the main of this same repo built in 5 seconds. But when we build this, which we'll be doing in a sec here, VM, yeah, we'll just make a deployment for this. Sorry, detail get deployments. Oh, what is it called? It's called Spring Boot Graal VM demo. Spring Boot Graal demo. Okay, so there's no Graal demo. We're going to make one. It's a very similar deployment to what you've seen before. It's actually pretty much the exact same deployment as the main, because we're just putting up an image in standard fashion. But if we check the logs, kubectl logs f deployment / Spring Boot Graal demo, see that it started in 0.014 seconds, so 14 1,000ths of a second. And the JVM was running for another 2 1,000ths of a second longer than that. So these are near instant start times. And so when GraalVM boasts about high performance JDK distribution with, they say something like 50 times performance, something like that, they are not kidding. I'm sorry, I can't find the links right now, but yeah, they really do have this capability. It's very exciting to me because I think what new use cases are coming out. Like right now, I think because this is still experimental, a lot of things don't have support for, like they don't have all of the right dependency setups to be able to build natively out of the box. But once they're in place and once this is more widely usable, what other use cases can the Java community make use of? Like where can we put this solution is what I'm wondering. So I'm excited to see what happens when this is further along. I hope you are too. But it's up to you. And we have nearly reached the end. Just a couple of parting thoughts before we go. I remember being in a different organization and going to conferences and thinking, well, all that looks cool, but it is too big of a lift. May not fit in my team's schedule or may not fit into my org's appetites for like projects to take on. So if that is something that you're thinking, I can kind of relate. And I think I have some suggestions that may help to get the refactor conversation started. If you think some part of this might be useful for you in your job, you could trying it with a new service, like trying Kubernetes with a new service. It seems like it may be a cost at first to say, we're just going to train a couple people on Kubernetes, or we're just going to fracture our DevOps space. But there are benefits as well. You get the benefit of, say you only put one service out of your entire architecture in GKE or in whatever cloud system you want. You can get the benefit of that cloud's provenance tools, which could highlight dependency or security issues for not only the app that you put in there, but any apps that share dependencies with that app. So that could be a bonus. You could also break off and containerize unpredictable workloads. There may be workloads that your organization has just become okay with spending more than they need to for an unpredictable or occasional workload that may be a good candidate for a GRAL, especially if it can kind of be broken off into its own small app, because dependencies can be a real issue when you're trying to AOT compile a larger app. But I mean, I would say give it a try. And then I'm just going to come back to promoting Liquibase and test containers and Kubernetes as VPC to, have a secure, stable, evolving and replicable database that you can build and deploy to, whether you're on local or on prod, and have it act the same way. I think there's just a ton of merit to this setup. I think that's kind of like an evergreen thing in an organization to say, I want our databases to be as robust as our code, and I want us to be able to roll back to any point in time if we need to, and know that our database will stand up properly. So I think that's something that, at least in my experience, I've had success bringing it to the table in architectural discussions. And last but not least is Anthos, which somebody asked about, which I was not expecting anybody to ask about, just because it's so niche. And so, yeah, as I mentioned, Anthos is an application management platform that provides consistent development and ops experience for both on cloud and on-prem environments. There is a good like Anthos docs, like there's a concept overview that might be helpful, and then also in the document that I linked, there is a good user story for like lifting and shifting a VM-based legacy app to Anthos. All right, and with that said, we have covered everything that I wanted today. This has been a lot of fun. Thank you for your questions. Thank you for your time. As a reminder, I am here and free to chat for the networking portion for doing that. And feel free to reach out to me on Twitter if you have any other questions. Thank you for having me.
Awesome talk, Aaron. Thank you very much for that. Niha, do we have questions?
I don't see any more questions, actually. I was just checking. People are saying great talk, awesome, and excellent presentation. And the link seems great. So thanks, Aaron, for sharing all that.
No problem.
So let me do one question. So some people say that Kubernetes adds too much complexity to your application. What's your thoughts on that?
So I've definitely been in situations where the job we actually need to do is pretty simple. If we're just hosting basic web apps, we're not doing a whole bunch of dynamic changes, and we're not trying to scale to global scale and do all that, then in some cases it may not be worth onboarding every dev in a small dev team to do that. But I think that if you are struggling with rough deploys and your config being out of sync and the apps going down all the time, then I think it's worth a try.
Makes sense. Makes sense. All right. So we're gonna do our raffle. If there is no other questions, let's go to the raffle. So Barry gonna come here to explain the raffle rules. We have 2 JetBrains license, so it can be used to any JetBrains product, IntelliJ included, 1 year subscription, and 1 year one Agile Learner subscription. So Agile Learner is from Venkat Subramania. So here we have the JetBrains logo, one of our sponsors, the Agile Learner, the other of our sponsors. So Barry, you want to come and explain the rules?
I will explain the rules. The first raffle that we'll do will be for JetBrains. We have 2 licenses. If you look at your screen, you'll see a spinning wheel with the numbers 0 through 29, 0 index, of course. What I invite you to do is in the chat, put a number, your guess, and the 2 closest modulo 30 will win the IntelliJ raffle. In case of a tie, we'll scramble for ideas.
All right, so we have numbers coming in. Let's see. All right, let's go.
All right, I'm going to wait for
Numbers
I'm going to wait for another few seconds here.
Yeah.
Type a number between 0 and 29, inclusive, in the chat window, and then I'll spin the wheel.
Right, come on.
And by the way, Rodrigo and Neha, I'm going to ask you to scan the numbers after I've done the spinning, okay?
Sure.
All right, here we go.
People are still typing numbers.
Okay.
Oh,
All right,
I guess.
so we have one.
Shall we spin?
14 people type the numbers. 15.
Yeah.
All right, let's get
Time to
started.
spin. All right. Whoops, people still coming in.
Yeah.
All right, here we go.
All right, first one. Let's go.
Boom. I feel like playing game show music at this point, but maybe we'll do that next time.
We're like
And I'm going to stop the wheel, and it
you're
stops
like
on 6. What winners do we have?
6. Let's see. We have Masa Nakahara, number 5. And that's it. So Masa, you were the winner. Please send your information to info@javasig.com and we'll send you the information. Squid Games. All right. Let's another one, Mary.
We will spin again, and we'll
Big
go by
numbers.
these numbers that people have already typed in. So are you ready? 1, 2, 3. Time to spin. Music, music, music. Drum roll, tension.
Aaron, do you have a fake name participating in the raffle?
No, but I did pop into the chat to see how many are there. Yeah.
All right, here we go. And
The
I'm
odds
going to
are pretty
stop
good.
the wheel. Boom. 26.
26. Oh, I see 25 and 27
We
and
have
27. All right. So we have Veer 27, Samir 25, Serge 27.
We need a runoff spin.
You know, Christmas is around the corner. Maybe we can give them. We have 1, 2, 3 winners.
Shall we do that?
We can do that. All right. Christmas got earlier for you. So please,
Wow.
all 3 of you, please email info@javasig.com. Barry, you can put on the chat, please, the email with your information. And we'll send. So it's Veer Div number 27, Samir Patel 25, and Sergio Rizov 27. Barry, one more spin for the Agile Learner from Venkat.
Okay. I got to share the screen again.
Yes. And while Barry spin up the wheel again, we're gonna have an after party. We're gonna put the link here on the chat. So if you wanna join us, Aaron's gonna be there. We're gonna be there. If you wanna come talk about anything Java related, not Java related, Kubernetes, whatever you want, just some get together. We'll be waiting for you.
Okay, here we go. We've got the wheel up. We've
Go
got
for it.
info@javasig.com on the chat. So the winner will please get ready. Here we go. Most of the game show music for spinning wheels is probably already under copyright, but I'll find something.
You can go to Jeopardy. You can be the host.
Yeah, that's it. They need one. Okay, here we go. Ready? Boom. 8.
8.
Number 8.
I didn't see an 8. All right.
Who's closest to 8 who hasn't won yet?
So maybe Maya number 12. Massa was number 5 and won already. Prussian's number 11. So we have Prussian number 11, and we have.
I think we've got, is that 5 and 11 that are both close to 8?
5 and 11, but Massa cannot participate. So Prussian number 11 is the closest one.
So we've
Am
got
I
it,
right?
Yep.
All right.
That's right.
Prussian, you won a 1-year subscription to Agile Learner from Venkat. All of you, please.
info@javasig.com, your email.
Yeah, exactly. Perfectly. So Barry put here the after party link. We're gonna go there in a few. Our next event is a hands-on workshop on quantum computing for the Java developer on October 27th. So very nice topic. The registration is gonna open soon. There's a limited seats for hands-on workshops. So run if you wanna participate. And to be notified, you need to be following us on Twitter and our website, so you are aware of our next event. So follow us, and you can, luckily you can be one of the participants, right? So thank you very much for being with us tonight. Aaron, thank you very much. I'll see you in our after party.